Hey everyone. So I think today I want to try and show you guys how I'm going to try to use Leetcode to learn C++. Uh, Basically, I still feel a little bit not too familiar with the mechanics of like manipulating data slash using variables and data structures. And I think that me solving some familiar problems that I've solved before with Python, but trying to solve it in C++ would basically kind of help me get more comfortable with using the language. So this is just the first video. I might make a few more of these if you guys are interested in this, but we can kind of compare and contrast some of the differences in the implementations between Python and C++. So I'm going to solve this Leetcode number one TwoSum problem, which hopefully is familiar to most of you if you've been studying Leetcode. And this isn't meant to be a complete tutorial on how to solve the problem, but it's more about me learning the syntax and usage of C++. So let's get into it. I'll read through the problem. So TwoSum, it's an easy problem. And given an array of integers nums and an integer target, return the indices of the two numbers such that they add up to target. Assume that each input has one solution and you cannot use the same element twice. Return the answer in any order. So maybe I can do a quick drawing of this. And so I've already solved this problem before in Python. So I know the solution. And the solution we'll use today is the hash map solution, which is the most optimized for time complexity. It's an O of n operation or O of n solution. But basically, you're given an array nums. So you could have these numbers in the array. Oops, that's a 15. And you want to find, and you're also given a target. So target is, in this case, 9. So I'm copying this example from down here. And the solution is you want to output the two indices of the numbers that add up to 9. So index 0 would be the number 2. Index 1 would be the number 7. 2 plus 7 equals 9. So the optimal solution is that we are going to create a hash map. And we're going to then iterate through the array. And for every iteration, we're going to calculate the complement of each number that we're looking at. So for example, what I mean by that is the number, in the first iteration, we're looking at the number 2. So our complement, which is the number that we need to add to 2 to get to our target number, will be equal to 9 minus 2, or target minus 2. And that complement will equal 7. And then what we need to do is check if we've already seen a number, the number 7 in our dictionary. And if so, then we can know where that number was because we'll store it in the dictionary, which I'll show you guys. But if not, we'll just continue searching through the rest of the array until we find our two numbers. So in this case, since our dictionary or our hash map is empty, we actually will add the number 2, which is the number we're currently looking at, as the key in the hash map, and the value will be this number's index. The reason why we do that is because when we move on to the next number, when we're looking at 7, we calculate its complement by doing 9 minus 7 equals 2. And then again, we check to see if the complement is inside our hash map, and it actually is here. And now we know the index of that number, complement number, which is 0. And now we can immediately return the index of the current number and the index of our complement as our answer, which is 0 and 1. So that's a quick explanation of it. If it didn't make sense, you guys can probably go watch like NeetCode's videos or just look it up on YouTube and find a better explanation of it. But let me go into my Python implementation and see if I still remember how to do Python. It's been a while. But like I said, we will create a hash map. So I'll call it scene because these are the numbers that we've seen so far. And then we will do a loop. And I'm going to do index and the number. So what I'm doing here is this enumerate function is going to return like a tuple of the current index that we're looking at and the number. And what did I say we're going to do? We're going to calculate the complement. So the complement will equal our target number minus the current number. And then we're going to check if complement is in our scene. We can immediately return the array current index. Maybe we'll do the complement index. So it'll be, we'll grab the index from our hash map and then the current index that we're at. If we do not see the complement in scene, then we will just add the current number to our hash map. And hopefully if I did this correctly, we can run it and see if this passes. We pass our 3 test cases and we can submit. And it looks like I still remember how to do it. And let's try it in C++ now. All right, so let's take a look at what we're seeing here. So they have, this is just the way that Leetcode does it. They put our solution inside of a class called solution, and our implementation is under this public, it's a method under, it's a public method. And it looks like this one is going to return a vector vector of integers, which is the same thing as an array, I guess, a dynamic array in C++. It's going to take in a integer array again, a reference to an integer array or vector called nums, and our target is an integer. So let's see if we can do the same approach. And also, by the way, it looks like they're using namespace standard or STD. So I guess I will omit that from my solution here. But what did I do first? So we want to create a unordered map. So we can use unordered map. And I think you need to give it the type. So it'll map an integer to an integer. We will call this scene again. And I think that's how you create the map. This looks wrong to me, but I guess that's correct. And then we did a for loop. So let's see, I don't know if there's a way to enumerate, like to get both the number and index. So I guess we will just do index for now. So we can create an integer called I. We want to go up until the size of the input array. And I actually don't know how to get that. So let me Google that. Dot size. Okay, so we can use dot size. So we want to go up until nums dot size, and we can increment by 1. So that's our for loop. And then what did we do? We want to calculate the complement. So we can say our complement will be an integer, and it will be equal to target minus the current number, which will be our nums array at index I. And then we want to check if this number is inside of our map. How do we do that? We can say if. I also don't know how to check that, so we can say how to check if num is inside map. Using contains C++20 and later. Returns a Boolean. Okay, so that seems like it'll work. So we can say if our scene map contains our complement number, let's see, we want to return a vector of int, and we will give it the values. Let's see, we can access the value of the complement inside of our hash map like this, and then our current index. I think that's correct. And then if not, then we need to store it in the hash map. I believe we do the same thing like, or sorry, what are we storing? We're storing the current num, which is nums at I. And we're setting its value to be I. I think that's correct. So hopefully this logic tracks, and let's see if this runs. Compile error. So line character 5, non-void function, does not return a value in all control paths. Okay, so we need to return something if we break out of this loop somehow. So I guess we can, what do we want to return? So it's the return type of this function is a vector of integers. So maybe we can just return a vector of integers that's empty perhaps. And let's see if this works. Another compile error. Expected member name. Can I not initialize a vector like this? Let's see. Return vector of type int given these two values. It seems like that's the way I'm doing it here. We'll ask Gemini how to fix this. Oh, I think I just put it in the wrong brackets. So I think there's an auto format here. Okay, I think this should work if we just leave this as empty, an empty vector now. All right, and now we get the wrong answer because there's no output for some reason. So why is that? Is this one returning anything? No, okay. Let's see. So let's see if my logic still tracks. We're doing a for loop up until the end of the vector. We're calculating the complement, target equals nums at I. If scene map contains complement, return the vector scene at complement, comma I. If not, then we are going to add the current number that we're looking at to our scene map, and its value will be its index. Seems like something's not working here. Let's use Gemini again. Local variables are not automatically set to 0. Okay, we need to initialize this to 0. Sweet, okay, looks like it works now. And let's see if when we submit, it'll pass all the test cases. Perfect. And it looks like we have the most efficient solution. Cool. So yeah, I think that's what I wanted to show. Basically, if you want to take a look at this implementation in C++ versus the Python version of it, this is why I would recommend using Python for coding interviews. There's just a lot less overhead to keep track of like all your brackets and parentheses for like making for loops and stuff. I think Python really simplifies the syntax. But seems like it's still doable in C++. All the logic is the same, but it's just a matter of getting used to this syntax and some of the smaller details for C++. Also, one thing, I just checked Gemini and I asked it if this is like standard. And actually, I think this is fine. But since we're specifying the return type of the function here, we actually don't need to use this notation here. And we can simply return, just the integers in the bracket like this if we wanted to return like -1, -1, or leave it as an empty, I don't know what you would call this. Basically, since we are specifying the type here, C++ is smart enough to know that whatever we put here as our return value, it can pass this into our constructor for creating a vector. That kind of confused me because I thought that this was like the notation for creating an array. But since the return type is specified here, this is good enough. So I think we can do the same thing here. Let me just double check that works. We can run it again. Yeah, seems like that still works. Nice. And I think the benefit of that is if you wanted to like later change this return type to maybe something like array or a different data structure, I think it's better because you don't have to change that the type of the return value here and here if you wanted to refactor your code. All right, thanks for watching, and let me know if you guys like this kind of content. I can make more of these Leetcode videos. Also have cool other projects planned. But thanks again for everyone for watching, and thanks for all your support. See you next video.